Lesson 1.3, distance and midpoint. So upon completion of today's lesson, you should be able to find the distance between 2 points, as well as find the midpoint of a segment. So first we're going to talk about the definition of a distance formula on a number line. It is the distance between 2 points is the absolute value of the difference between their coordinates. So if point P has a coordinate of x sub 1, and a coordinate q has a value of coordinate x sub 2, line segment PQ is evaluated by taking the absolute value of x2 minus x1, or the absolute value of x1 minus x2. So by taking a look at our first example, we're going to use the number line to find the difference from B to E. Again, our equation is going to be B to E is equal to the absolute value of x2 minus x1. So the first thing we need to do is assign value. x2 I'm going to allow to be 2, and x1 I'm going to allow to be negative 6. Now I just substitute into my equation. So I have the absolute value of 2 minus a negative 6. When you have minus a negative, it becomes plus a positive. So we get the absolute value of 2 plus 6 becomes the absolute value of 8. Then we simplify the absolute value of 8 to be 8. Remember, absolute value is the distance from 0, which will always be positive. Now let's talk about the distance formula as it relates to 2 points. If P has a coordinate of x sub 1, y sub 1, and Q has a coordinate of x sub 2, y sub 2, then to find the distance between PQ, we are going to take the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. It is very important that if you put x sub 2 first, you are going to put y sub 2 first. If you put x sub 1 first, then you need to put y sub 1 first. So our first example says find the distance between C, which is negative 4, negative 6, and D, which is 5, comma, negative 1. So the first thing I always have my students do is I always have them label their point. I always go x sub 1, y sub 1, x sub 2, y sub 2. Now you can do this in the other order. You can go x sub 2, y sub 2, x sub 1, y sub 1, but make sure that your sub 1s and your sub 2s are together. So then we're going to write the distance formula. The distance formula is right here. So we have the square root of x2 minus x1 squared plus y2 minus y1 squared. I've already labeled these x1s, y1s, x2, y2, and so I'm going to substitute it in. My distance is equal to x sub 2, which is 5, minus x sub 1, which is negative 4. So I have minus a negative 4, and then that is squared. Anytime that you have minus a negative, it becomes plus a positive. And then plus my y values. My y sub 2 is negative 6. My y sub 1 is negative 1. Anytime you have minus a negative, it becomes plus a positive, and that is squared. All of this is underneath my square root. So my distance is equal to the square root of 5 plus 4 gives me 9 squared, plus negative 6 plus 1 gives me a negative 5 squared. So now I'm going to evaluate 9 squared gives me 81. Negative 5 squared gives me 25. You get a final answer as the square root of 106. I mean, a square root of 106. So now we're going to talk about, again, this time we're going to start with the midpoint formula. We're going to talk about it on a number line. If AB, so if line segment AB ends at x1 and x2 on the number line, then the midpoint M of AB it has the coordinate x1 plus x2 divided by 2. So if you take a look at this example, in example 3, and I want to know what the midpoint is on this number line. Okay, we are told that the picture, the endpoints at the top of the picture are at 15 inches and at 37.5 inches. And I want to know what is the midpoint of that. So I want to start by using the midpoint formula for a number line. It is M is equal to x1 plus x2 divided by 2. My x1 value is going to equal 15. My x2 value is going to equal 37.5. So now we plug it into the equation. We have 15 plus 37.5 divided by 2. We simplify the numerator. We get 52.5 divided by 2 for a final answer of 26.25. That is my midpoint of A to B. Now we want to find the midpoint formula in the coordinate plane. So if we have PQ, line segment PQ, and it has endpoints at P, which we are calling x sub 1, y sub 1, and Q, which we are calling x sub 2, y sub 2, in the coordinate plane, then we can use the midpoint M of PQ as of the following formula. M is going to be x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. So example 4, it asks you to find the midpoint of ST. And just like we did above, the first thing I'm going to have us do is we are going to label our points. And again, I always go x sub 1, y sub 1, x sub 2, y sub 2. Remember, your equation is for your midpoint is x sub 2 plus x sub 1 divided by 2, comma, y sub 2 plus y sub 1 divided by 2. So now I plug in my values, trying to find the midpoint. My x sub 2 is 1, plus my x sub 1 is negative 6 over 2. My y sub 1 is 0, plus, or my y sub 2 is 0. My y sub 1 is 3 over 2. I want to simplify this. 1 plus a negative 6 gives me negative 5 over 2, comma, 0 plus 3 gives me 3 over 2. And if you would like your answer in a mixed number, you would have negative 2.5, comma, 1 1/2. Either one of those two answers will be correct, whether you leave it as an improper fraction or a mixed number. Now, I would like for you to try and solve example 5 on your own and come to class with that done on Wednesday. And then finally, we're going to look at example 6, where we are going to use algebra to find a measure. The question it asks us here is it asks us to find the value of PQ. It wants to know what is the distance from P to Q if Q is the midpoint. The piece of information we need to know is Q is the midpoint. With Q being the midpoint, it allows us to be able to say that PQ is equal to PR.